In this lesson, we're going to continue our study about the basic concepts of functions. This will be part C of our study on the basic concept of functions, and in this particular part, we're going to be looking at determining the domain and range of a function given the graph. Now, before we begin, just remember about our definition of domain and range. So the domain is the set of x coordinates, so the set of x coordinates. And the range, remember, is the set of y coordinates. Okay, now in the examples we're going to use for this part, for part C, for lesson 1 in particular, the examples we're going to use for lesson 1, you're going to see that the end behavior, and I'm going to talk about what I mean by end behavior from the graph, you're going to see that the end behavior of the graphs have arrows. Okay, so on both sides. So you can have arrows on both sides. Okay, that's going to be lesson 1. So for example, let's go ahead and look at this first problem. Okay, so here's the graph of a linear function. Okay, so it's a line, so you know it's a linear function. And there's the graph. And so in fact, if you think about it, this particular function has this equation. So the function is f of x equals 3/4 x minus 3. All right, so that's a linear function. Now remember, I wrote it in function notation, but remember you can always write it as, remember f of x here means the same thing as y, so you can always write it as y equals 3/4 x minus 3. All right, so remember function notation. So notice that that's a linear equation, and so if you use the idea of slope and intercept, do you remember that this is in slope-intercept form? So slope-intercept form. And so when you graph it, here's the y-intercept. There you see it right here. And we use the idea of slope, rise over run. You go up 3 to the right 4, excuse me. And so notice 1, 2, 3, 1, 2, 3, 4. And so you get this line. All right. But the point here is I wanted to show you that this was the equation of a line, and here's that particular equation of the line, of this particular function. What I'm interested in, though, is finding the domain and range of this function from its graph. Find the domain and range of this function given its graph. A while ago, I mentioned to you that the end behavior of the graphs will have arrows. So what I mean by end behavior is this. What's happening on the end of the graph? So notice on the right side of the graph, you have an arrow. On the left side of the graph, you have an arrow. This idea of end behavior is going to be important in another chapter. But for us right now, we're not going to go into that chapter just yet. I just want you to know what we mean by end behavior. So the behavior on the right side, so that's the right side, and this is the left side. All right, so notice the right side and the left side both have arrows. Okay? All right, so here's what I would do to determine the domain and range given the graph. It is very important that you use a tool to help you with this. So for example, use a ruler if you need to. Use a ruler to help you to determine the domain and range given the graph, and you can see what that's going to look like. Okay, so listen carefully. The domain is a set of all x coordinates on this graph. So if you notice, this graph has an infinite number of points. Infinite number of points, right? So the domain is going to be the x coordinate of all of these points. So to determine the x coordinate, I want to show you something. If I look at this point here, this point right here, okay, right here, and I kind of use my ruler to intersect that x-axis. So it intersects that x-axis at 1. So that means that this x-coordinate is 1. Okay? If I go further, right here, that's probably 1.2. If I go further, now listen carefully to my words. This could be 1.2756, right? This could be 1.99999 and so on. This right here, this point here could have x-coordinate 5.234. What I'm pointing out is that many students, when they think of of points, they think of integers. It's not just integers. It could be any real number. Any real number could be an x-coordinate of these points, a rational number or an irrational number. Okay? So when there are arrows on both ends, it's kind of the easy thing to deal with. Okay, so listen carefully. You see how this arrow is pointing down? So just think about it like this. It just keeps on going down like this, and this keeps going up like this. Okay, so that's how you got to think. Now the domain is a set of x-coordinates. Domain is a set of x-coordinates. So go along the x-axis like this. See how the ruler is going along the x-axis? You see that? Okay. So notice that since it's going down, it's on the x-axis on the left side, it's not bounded. Think of negative infinity. You see how this arrow here goes -10, -100, -1,000,000, and so on? So I'm going from negative infinity, all the way. See, it doesn't stop, right? It doesn't stop. I still have a graph. Does this ruler still touch the graph? Yes, it's still touching the graph. It's still touching the graph. It's still touching the graph, and so on, right? It's still touching the graph. The arrow doesn't mean it stops. It means it keeps on going. It's still touching the graph. In fact, it touches the graph all the way to the idea of positive infinity. So the domain. Now, since there's an infinite number of points, you have to list it as an interval. You must list it as an interval in interval notation. All right, so the domain will be, and remember this, with infinity and negative infinity, you always use parentheses. Infinity and negative infinity. All right, now here's how it looks. Watch. This is positive infinity. It looks like a sideways 8. Many students think of it that way, but make it look like this now. And this is negative infinity. All right, so infinity, negative infinity, you're always going to use parentheses. You're going to use parentheses. Okay, that's important to remember. That's important to remember. Infinity, negative infinity, you will use parentheses. Okay, so watch. Let's talk about the domain again. The arrow, let me kind of make that a little bit smaller so I don't have to keep moving it. All right, so the arrow implies it keeps on going down. So this line goes all the way down like this. So that means when I go along the x-axis, it's not bounded. There's no starting point. There's no dot there. It's an arrow. Okay, so I'm going from negative infinity all the way, and you got to think about where are you going to stop. You don't. You keep on going. You see, the ruler, that blue ruler touches the graph at some point. Keeps on going, keeps on going, keeps on going. You guys think about visually what's happening here. Keeps on going all the way to positive infinity. So the domain will be parentheses, and you always go from smallest to largest. Let me make a point here. Go from smallest for interval notation. You always go from smallest to largest. Okay, so that's why when we talk about the x-axis, we always go from left to right. Because notice, -10 is smaller than -6, is smaller than 0, smaller than 4, and so on. Always go from smaller to larger. So for the domain, you're going to say negative infinity to positive infinity. Notice parentheses. Now let's talk about the range. The range is the same idea. Remember, the range is a set of y-coordinates. Range is a set of y-coordinates. So when we talk about the range, you go along the y-axis, but you go from small to large. See, these are negative down here, and these are positive. So you're going from bottom up. Okay. Now I'm going to ask you this. So you see, remember this line keeps on going down. So you have to visually think about this line going down, all the way down, all the way down. All right. So you got to think about it, this infinite plane. So this arrow down here is pointing towards negative infinity. This arrow up here is pointing towards the idea of getting to positive infinity. So since there's no bound, since it keeps on going down, I am going from negative infinity all the way. See, I touched part of the graph, right? All the way. So I'm still touching the graph. I'm still touching the graph. So when y is 1, there's a point on the graph. When y is 1.5, there's a point on the graph. When y is 5.12378, there's a point on the graph, and so on. So I'm going all the way to, see, you got to visualize this going down. You got to visualize that ruler extending like this, keeps on going to positive infinity. So my range is from negative infinity to positive infinity. Okay? All right. Let's look at the next one. All right. So the next one is this. Now we have this idea. So notice this graph right here. So we have this function. You have arrows on the end behavior. See, this is your end behavior. What happens on the right side? You have an arrow pointing up. What happens on the left side? You have an arrow pointing up, right? Okay. Now let's talk about the domain. The domain is the set of x coordinates. So you take your ruler and you move along the x-axis like this. Along the x-axis, always along the x-axis, because the domain is a set of x coordinates. You have to remember, though, that this arrow, you got to visualize it going up like this. All right? So you got to remember, you may say, well, it looks like it starts here because that's where that arrow is, right? No, it's not. Okay? It's because this arrow, remember, you got to think it's keep going up like this. Up, look, up and to the left. Up and to the left. This is up and to the right. Up and to the right. Okay? So I'm going to ask you, if this point right here was negative 1 million, if x is negative 1 million, is there a y coordinate on the graph? Yes, somewhere way up there. And this way, this is negative 1 billion. Yep, somewhere up there. So I'm going from negative infinity, all the way. Any of these real numbers of x will have a point on the graph. All the way to, now remember, you got to visualize it going up, okay? This arrow, got to visualize that arrow going up. So you're going from negative infinity all the way to positive infinity. So if you think of this right here as being 100 billion, if x is 100 billion, there's a point in the graph, because this you got to think up and to the right, okay? All right, so domain is negative infinity to infinity. Now let's talk about the range. Okay, now I want you to notice something. For this particular graph, the end behavior were pointing both up, okay? When we talked about this right here, I want you to notice the end behavior. The end behavior, the right side was pointing up, the left side was pointing down. See that? And I want you to notice about your domain and range. They all had infinities and negative infinities. When I look at this one, both end behavior are pointing up. So let's think about what's going to happen to the range. Okay. So if you notice that this parabola, and by the way, this is a quadratic function, this particular one, and in fact the function is this. It's f of x equal x squared plus 4x. So f of x equal x squared plus 4x. That's this function. All right. So I want you to think about the range now. You go from bottom up. So think about what's happening. So when I go, when I'm on -8, when you look at -8 right here, is there a point on the graph anywhere on that graph? No, because remember, doesn't it start here? That's where it starts, right? That's the lowest point. If you think about it, all these are points on the graph. This is the lowest point on the graph. So my question to you is, what is that y coordinate? Remember, the range is a set of y coordinates. So the y coordinate here is -4. All right, now listen carefully. -4, see, this point is on the graph, right? So since this point's on the graph, all these points on the graph. So that means that if I'm going to say that -4 is the lowest point, I must use a bracket. A bracket, not parentheses. You use parentheses You use parentheses when we talk about infinity, negative infinity. Negative 4 is a point on the graph. Since negative 4 is a y-coordinate, since negative 4 is part of the range, remember every point here, the y-coordinate is in the range, I must use a bracket. If you use parentheses, that means that negative 4 is not in the range, but it is because it's on the graph. Okay, so you're going to get a little bit better with understanding parentheses and brackets in the next lesson. In lesson 2, you're going to see what I mean by that. All right, so the range starts at negative 4. That's not an arrow, right? That's not an arrow, so make that a bracket, not a parentheses. Lesson 2, the next lesson, you're going to understand some of that will have parentheses, and you're going to see why. But negative 4 is in the range. It's on the graph. It's right here, negative 4. This is the point, watch. This is a point, negative 2, negative 4. So there's your y value. That's a point on the graph. So negative 4 is the smallest y value. And remember we said that you always go from smallest to largest in interval notation. So you're going to say negative 4 all the way, all of these y coordinates. So if you look at the y coordinate 1 right here, there are 2 x values that have y coordinate 1 and so on. But all the way from negative 4 all the way, it never stops. See, these arrows keep going up all the way to infinity. So you can say negative 4 comma infinity parentheses. Remember, infinity, negative infinity, we use parentheses. So that's your range. All right, so the domain, you go from negative infinity to infinity. The range, when you go from bottom up along the y-axis, this is where the graph starts, right here. Negative 4, all the way. It never stops because these arrows keep going up all the way to infinity. All right, so let's look at another one. What about this one? What if I had this quadratic equation? What if I had this one? All right, so let's find the domain and range. Now notice this time the end behaviors, there are arrows on the right side and arrows on the left side, except this time it's pointing down, right? Okay, so here, here it was pointing up. So let's compare. In a little while, we're going to compare the range with each other, with this one and the range with this one. Okay, let's talk about the domain. The domain, remember, is the set of x coordinates. And so remember, you got to think this arrow, you're going down to the left like this. You're going down to the right like this. So this right here was negative 100 million. Would you get a point on the graph? Yes, somewhere down there, way down there, you get a point on the graph. So you're going from negative infinity all the way to positive infinity. When you have parentheses, when you have negative infinity to infinity, you must use parentheses with it. Make sure I understand that's a parentheses. If it looks like a bracket, when it's supposed to be a parentheses, you're not going to get full credit. Okay, so make sure you distinguish between brackets and parentheses. Let's talk about the range now. Remember the range, you go from along the y-axis from bottom up, like this. So use a ruler to help you, or use something to help you. But notice that these are arrows down here. So in terms of where does the graph start, well, there's really no bottom to it, right? It keeps on going down. So since there's no bottom, since there's no smallest point, in other words, like over here, there was a smallest point. So it's kind of like, think of a bottom. So there was a smallest point. So that was the smallest y value. Here, the arrows keep going down. There's no smallest point because it keeps going towards, and what's that idea? Negative infinity. So I'm going from negative infinity all the way, watch what happens, all the way, and this is where I stop, right here. That's where the graph stops. So there's a maximum right here. This is your maximum, and the maximum is at 7. So this point right here, it looks like it's what, 3, 7? 3, 7? And so your range will go from parentheses negative infinity all the way to 7 with a bracket. 7 is in the range, so I must use a bracket. All right, so that's the range. All right, let's look at another one. So suppose we had this one. All right, we had this absolute value equation. And this absolute value equation has this function. So this is the function f of x equal 2 times the absolute value of x minus 1 minus 6. So that's the function right there. So that if you were to graph this, this is what you would get. If you do a t-table and get enough points, this is what you would get. All right? But let's talk about the domain and range. First of all, notice the end behavior. Always look at the end behavior. It helps when determining domain and range. On the right side, you have an arrow pointing up, so it keeps on going. On the left side, you have an arrow pointing up, keeps on going. Okay? So in terms of domain, it's going from, is this where it starts? No, right? Because it keeps on going up. So you're starting from negative infinity all the way to positive infinity. So negative infinity to positive infinity. Okay? Let's talk about the range. The range is a set of y coordinates. So go along your y-axis from bottom up, from smallest to largest. Notice that the arrows are pointing up, right? That's important to realize. It's pointing up. So this right here is your lowest point. So when I go from bottom up, this is where I touch the graph. So let's talk about this point right here. So that's the point 1, negative 6. Since I'm talking about the range, this is the smallest y value. So I'm going to say bracket negative 6, comma, all the way, and remember the arrows keep going up, it never stops, all the way to infinity with parentheses. Okay? Again, make it look like a bracket, make it look like a parentheses. So that was that one. Let's look at the next one. All right, suppose I had this absolute value equation. Notice this time the arrows are pointing down. On the right side it's pointing down, on the left side it's pointing down, like this. So the domain, when you go along the x-axis, think of this as negative infinity right here, negative infinity. So you're going to get a point in the graph. So I'm going from negative infinity all the way to, it never stops, right? Because the arrow keeps going down, all the way to positive infinity. So parentheses negative infinity, parentheses positive infinity. The range, notice the arrows are pointing down, right? So there's no lowest point. So you got to think this is kind of pushing the ruler down. So you're going from negative infinity all the way to, and then there is a highest point right here. You can't go any further. You're done. So there is a highest y value. There is a maximum y value, and it is negative 2. So this is the point right here, negative 4, negative 2, and so that y value is negative 2. So you got to say from negative infinity, always go from smallest to largest. Negative infinity to negative 2. Negative infinity, negative 2, and you got to remember, since negative 2 is a y value on that graph, see negative 2 is a y value in the graph and it's the largest, you got to use bracket. All right, so that was that one. Okay, let's look at this one. All right, so notice this graph right here. So notice the end behavior. On the right side, the arrow points up. On the left side, the arrow points down, right? Okay, so and I want you to think about that line we did earlier, where your line had arrows on both ends, one going up, one going down. So remember, this keeps doing this, and this keeps doing this. Okay, keep that in mind. So if this were negative infinity right here, well, let me rephrase it. If this were negative 100 billion, let's say, would you get a point in the graph? Yes, it'll be way down here. So I'm going from negative infinity all the way to positive infinity, because remember the graph keeps going up. So from negative infinity all the way to positive infinity. So that's your domain. Now let's go about the range. For the range, you're going to go along your y-axis. So again, notice the idea of negative infinity down here. So if this was negative 100 billion, you get a point on the graph, right? Somewhere around here. So you're going from negative infinity all the way to, it never stops, the arrow keeps going up all the way to positive infinity. Okay, always go from smallest to largest. Negative infinity to infinity. Okay, another one. All right, let's look at this one. So again, notice the end behavior. So this goes down. The right side is going down. The left side is going down. But have arrows on both ends. All right, so let's talk about the domain. So the domain, you're going from, so you're gonna, the arrow keeps going down, right? The graph keeps going down like this. So this ruler's touching that graph. So you're going from negative infinity all the way to, keeps going all the way to, keeps going, right? You're still touching the graph all the way to positive infinity. Okay, let's talk about the range. So notice that both arrows are pointing down like this. So you're going from, since both are pointing down, you got to think of this right here like, let's say, negative 100 billion. If y is negative 100 billion, you get a point on the graph? Yes. In fact, you get 2 points on the graph. So it's arrows pointing this, pushing this down towards the idea of negative infinity. So you're going from negative infinity all the way to, and then notice, be careful. So you see a little hump there, right? But that's not the highest y value. That's not the largest y value because it can keep going up. See, when x is 2.5, you get points here. When x is 3, you get points here, and so on. So this is the largest y value. You can't go any further. This is the largest y value. So that point is negative 4, 5. Negative 4, 5. And so there's your highest y value. So the range, you're going from negative infinity to 5 with a bracket. Okay, so negative infinity, keep on going, don't stop there because you still have some graph here. Keep on going, that's where you stop. And there's the y value. All right, the next one. Okay, let's look at this one. So notice the end behavior. On this side, you're going to the right. On this side, you're going down. Okay, so let's talk about the domain. The domain, so think of the idea of negative infinity. So this arrow keeps going down like this. So at some point, as you move, you're going to be touching that graph. So I'm going from negative infinity to, and never stops, all the way to positive infinity. All right, now let's talk about the range. So notice that the arrow keeps going down. So it's kind of like pushing this ruler down. So you're going from negative infinity all the way. You got to think about where you're going to stop. See, this is a horizontal ray right here. So you stop there because there's no other graph. See right here, there's no y value on that graph. This is where it stops. That's the highest point on the graph. In fact, there are infinite points that has the same highest y value. But all you need to know is that y value right here, this y value is 3. So you're going from negative infinity to 3 with a bracket. All right? So 3 is the largest y value on that graph. In fact, all these points, if you think about it, all these points right here have that y value 3. Okay, let's look at another one. Let's get this one. All right, so notice that this arrow is pointing to the left. So the left side points to the left, the right side points up. And so let's think about the domain. So the domain, you're going from negative infinity all the way to, notice the x-axis, so all the way to positive infinity. Okay, the range. All right, now notice that the arrow is pointing up. So think about as I go from bottom up. So this is really right here. This is really where I start touching the graph, right? All right, so there's no arrow. There's no arrow pointing down. It's actually pointing to the left. So the smallest y value in this case here is negative 5. All these points have y value of negative 5. All these points. The y value is negative 5. All these points. So I'm going from negative 5 all the way to, never stops, keeps on going, all the way to positive infinity. So bracket negative 5, positive infinity. All right, again, make it look like a bracket, make it look like parentheses. That's important. All right, and then finally, this is where some students get a little confused when it's a horizontal line. That's still a function. In fact, if you think about it, this is the line. This is the line y equal 3. That's the equation of that line. So remember, when in a previous course, when you're asked to graph y equal 3, you had to recognize that that was a horizontal line. There's no x. You see, there's no x variable. So y equal 3 means that y is always equal 3. So if you look at this, all these points, y always equals 3, right? Okay, so keep that in mind. So I can also write this as f of x equal 3 if I wanted to. So I can write its function notation. So this means that my y value is always equal to 3. So all these points that you're seeing me put my pencil point on, all these points, my y value is 3. So let's talk about the domain and range. The domain is a set of x coordinates. So if I see this arrow pointing to the left, the end behavior is pointing to the left, the right behavior, the arrow is pointing to the right. So I'm going from negative infinity all the way to positive infinity, right? So negative infinity all the way to positive infinity. So in other words, when x is, let's say this x value right here is negative 100,000, then my y value is 3. This would be my y value is 3. Whatever the x value is here, this would be my y value is 3. So I'm going from negative infinity all the way to positive infinity. Now let's talk about the range, and this is where you got to be careful. Notice in all the problems we've done at this point, we used interval notation. All of them, interval notation. And the reason we use interval notation, is because there are an infinite number of points in that interval. So for example, the range, I went from negative 5 all the way to infinity. So notice all of these y values, all real numbers, all decimals, all fractions, all real numbers, all rational numbers from negative 5 to infinity are in the range. So I had to use interval notation. So the idea of infinite set of points. Here, though, what is in the range? So if you go from bottom up along the y-axis, this is where you stop, and this is where you start, and this is where you stop, right? You can't go any further. This is it. That is it. Look at the y values. The y value in all of them is all what? This y value is 3. 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 They're all 3s. So how many y values are in your range? Don't say an infinite. These are all the same, right? So you don't list them. You don't list 3, 3, 3, 3, 3. You only list it once. So how many y values are in the range? Just 1. And so you're going to say this. You don't use an interval since it's a finite number. Remember in a previous lesson we used set notation. You just say this: the brace, 3, close, and you're done. That is your range. That's not a bracket now. It's a brace. It's a brace, not a bracket. Not bracket. So you say set, 3, open, brace, 3, and then close. Okay? All right. So that gets students right there when it's a horizontal line. All right. So that is lesson 1 for part C. And remember, in lesson 1 for part C, that's where we had arrows on both ends. We talked about infinity, negative infinity. All right. And so I want you to notice, if you go back to all of the problems, look at the domain. The domain on all of them was from negative infinity to infinity. And the reason the domain on all of them was negative infinity to infinity was because you had arrows. You had arrows on both ends. That's why. So notice arrows on both ends. Look at the domain. Arrows on both ends. The end behavior had arrows. Look at the domain. The end behavior had arrows. Look at the domain. Negative infinity to infinity. The end behavior had arrows. Look at the domain. Negative infinity to infinity. And you can keep on going. Arrows on both sides. Right side, left side. Negative infinity to infinity. arrows on both sides, -infinity to infinity, and so on. And then our very first problem, arrows on both sides, and -infinity to infinity for the domain. And in the next lesson, though, in lesson 2, when we do lesson 2, see, this was lesson 1. In lesson 2, both will not be arrows, so it's going to be a little bit different. And that's where we're going to talk about the idea of one side having a closed circle or an open circle, or both having closed open circle and not having arrows. So that's going to take care of lesson 1 for part C.